Today we're going to look at writing electron configurations or noble gas notation for ions. If we recall, an ion is a charged atom. So how do we form ions? Remember, we either lose or gain electrons. Okay? So our valence electrons are the electrons in the highest energy level, also called the outermost energy level, and that's because they're the furthest away from the nucleus. Okay, so if we look at cobalt, right, let's just write cobalt's electron configuration. We did that one yesterday. That should be at the top of your page there. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Alright, so if we look at that electron configuration, we want to find the electrons which are in the highest energy level to form a +2 ion. So if we're going to form a +2 cobalt ion, that means we have lost 2 electrons. To form a +2, there's a loss of 2 electrons. Now, which 2? Well, when we lose electrons, we lose the valence electrons, the highest energy level. And remember, energy levels are the numbers in front. So what's the highest number in front? Right, 4s. So those are the 2 electrons we're going to lose. So we're going to have 1s2, 2s2, 2p6, 3s2, 3p6. Now since that one's empty, we don't write it. And then 3d7. Alright, so then the orbital notation would work the same as it did yesterday. Right? Only we're going to eliminate that 4s. So we'll have our 1s with 2 electrons, our 2s with 2 electrons, our 2p has 3 orbitals and 6 electrons, then our 3s, and then our 3p, and then our 3d, because our 4s is still there, but it's empty. Right? And that's going to have 7. Okay? Our noble gas notation, right? So we would find cobalt on our periodic table, and our noble gas that came before cobalt would be argon. And so we would have argon, right, which stops at 3p6 right here, and so the rest would be 3d7. Again, we don't write the 4s in there because it's not being used. Okay. Let's look at one more example. We can just write it down here in this space. I want us to look at iron +3. Just as another example. It's a little bit different. So let's write the electron configuration for iron. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay? Now, if it's iron +3, that means we have to lose 3 electrons. Again, what 3 electrons are we going to lose? The valence electrons, which are the highest energy level. So what's the highest energy level? Again, that's at 4, right? So we're going to lose those 2, but that's only 2. We need 3. And so the third one will come out of the D. So that will be 5. And so the resulting electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, no 4s, and then 3d5. Alright, let's try a -1. Let's try sulfur. You should have sulfur written at the top of your page. sulfur is going to form a -2 charge. And so we'll have 1 S2, 2 S2, 2 P6, 3 S2, 3 P4. That's just sulfur. Now, if it's -2, that means we have gained 2 electrons. And if we gain 2 electrons, we add them in to the highest energy orbital sublevel we have. And so we fill in the holes, essentially, right? So we're going to add 2 more to this. So that ends up being P6. So the resulting electron configuration is 1 S2, 2 S2, 2 P6, 3 S2, 3 P6. Okay? So that's writing electron configurations for ions.